Comparing decimals. To compare decimal numbers, look at the digits from left to right. First, look at the digits from left to right. The number in the ones place is the same. The number in the tenths place is the same. The number in the hundredths place is different. The number on the left has a higher value in the hundredths place, so it is larger. We don't need to look at any of the remaining place values since we worked from left to right. First, look at the digits from left to right. The number in the ones place is different. The number on the right has a higher value in the ones place, so it is larger. We don't need to look at any of the remaining values since we worked from left to right.
Something looks different to me about these numbers. Let's compare from left to right to find out more. The number in the ones place is the same. The number in the tenths place is the same. Wait! The number in the left has a digit in the hundredths place, but the number on the right does not. What can we do? Since it is at the end, after the decimal point, we can write in the number that means nothing. 0. Now we can tell that the number on the left is greater. But why does adding a 0 to the end after the decimal place not change the value? Let's look at a model. On the left, we have 3 tenths, 1, 2, 3, and 3 hundredths, 1, 2, 3. On the right, we have 3 tenths, 1, 2, 3, and 0 hundredths. That's right, we don't have to color anything in for 0. The one on the left is still greater, and the 0 on the end of the right-hand number helps us better compare the place value, but doesn't increase the value. Let's look at another number with an uneven amount of decimal places. Working from left to right, we can find out more. The number in the ones place is the same. These numbers look awfully similar to me, so I'm going to use check marks when things are the same so I can keep track of my work. The number in the tenths place is the same. The number in the hundredths place is the same. When we get to the thousandths place, we see that the number on the right doesn't have a thousandths place. Never fear though, we know that at the end of a number, after a decimal point, we can add a 0 without adding value. I'm going to circle the thousandths place because the numbers are different, and this helps me see exactly which numbers I'm comparing. 2 is greater than 0, so the number on the left is greater than the number on the right. Let's examine our last number pair. Starting from the left, I see that the tens place is the same. The ones place is the same. The tenths place is the same. And the hundredths place is the same. The left number doesn't have a thousandths digit, but since it is after the decimal point, I know I can always add a 0 to the end without adding value. All of my place values are the same. This must mean that the numbers are equal.
And now for our final example. When you go to the grocery store, sometimes there are 2 boxes of the same type of cereal. The bigger box is usually more expensive, like in this case. But is the bigger box the better value? We have to look closer at the price tag to find out. This is the price per box. By looking instead at the price per ounce, the smaller number on the price tag, we can see that the larger 45-ounce box is charging 33 cents per ounce, and the smaller box is charging 50 cents per ounce. Which box is the better value? Let's compare the decimals. We always start from the left, so I'll examine the ones place first. They both have a 0 in the ones place. Next, I'll look at the tens place. The bigger box has a 3 in the tens place, while the smaller box has a 5. This means that the smaller box is more expensive and has a greater cost per ounce than the bigger box. Do we want the item with the greater cost or the lower cost? The lowest cost wins for providing the most value per ounce. That's all for comparing decimals. Thanks, and join us again soon.